All right, wonderful. Take two. So here we go. Welcome. Thank you for having me. And let's get right into it. So our giants are female. Just wanted to recognize two people, Kay Miles and Sumedha Genju, who are both advocates of mindful use of technology. And to me, they are looking to disrupt our industry in having us evaluate the role that our technology plays in industry. And so I'm actually excited to see what contributions they're going to be able to make. And as a software engineer, I find that keeping an eye on what we create with a thought on mindfulness, I think is key. So I want to applaud them, and I think fantastic. So a little bit about me. Oh, and like I said before, if you have questions, please jump in. This will be so much better if you have questions for me. So I'm a chief engineer. I've been at NI since 2002. I've used LabVIEW even longer than that. I've used LabVIEW as a user on many products internally and externally for NI. Some of my patents are all related to using LabVIEW. And the last time that I presented to a larger audience was now 2 years ago at NI Week. I have an eye for, or a passion for large systems, architecture, particularly when it comes to HAL-MALs, frameworks, extensions, etc. So this is, in a way, why this particular topic was keen for me. So this is what I plan to talk about. So I'll take some time to introduce what I feel is the problem statement. I do feel that we need a solution. I did take some time to evaluate other tools as an engineer. I feel like we are very quick to try to reinvent the wheel. And I wanted you to know that that wasn't my intention. And then let's talk about Solution Builder and what that actually is. So first, I'd like to start by reviewing some familiar concepts, and then I plan to use a little bit of a case study that, to me, highlighted exactly the problems that Solution Builder is aimed at trying to solve. So concept number one, hopefully you agree with me that code is well organized, it's componentized, it's either in libraries, it's in classes, but there is some relationship and code dependencies, concept two, between our code, which is either code that we own, code that we don't own, but there are these dependencies in these relationships. Concept three to me is that at some point I may have a lot of files, and my goal is not to ship or produce a large number of files, but instead bundle them in some way, similar to, let's say, a project library. The next one is if you are building these frameworks that have extensions, or you need to build something that needs to load something dynamically, specifically at runtime, then you need a mechanism in which to load that and use it. And so this is a very common concept of people doing that. You give it a path, you basically say, hey, I need you to be of this type. And if you match, then you pass and we get to use it. And then the last one is, at some point, if you're using a project, you likely have some build specifications in addition to just pack libraries, but you may have application, installer, DLLs, and so forth. So you will have some build specifications. So hopefully these are all good and you're nodding your heads going, yeah. So the topic of this presentation is about Solution Builder, but I'm going to use another project called Dependency Inspector as the case study for this, which to me highlight a lot of these issues that we're going to discuss. So for a brief moment, I'm going to talk about this project, just Dependency Inspector, just to make my point. So what Dependency Inspector does is, given LabVIEW hierarchy, a bunch of LabVIEW code, it generates a relationship graph of everything that is in use. I would argue similar to when you go into LabVIEW and you say, show VI hierarchy. The beauty of this one is it also allows you to collapse and filter some of the results and do these kind of things. So it's very useful to go, oh, does this thing depend or relate to this other piece as a validation mechanism? So the reason I talk about it is because the result that you're seeing on the right side is a DGML file. And if you don't know, that's a directed graph markup language, and it's used in Visual Studio. And so a lot of you might be thinking, well, that's great, but I don't use Visual Studio. So Dependency Inspector allows you to extend and actually implement an override for the exporter. So to basically say, hey, instead of exporting your data to a DGML file, export to XML or some other format or some other visualizer if you had one. And so then the question becomes, well, how does one normally do that? Well, a concept that's good in LabVIEW is the concept of LabVIEW interfaces. And so in this case, what Dependency Inspector has is an interface that's called exporter, and it defines a bunch of methods that a class can implement and override. And so this is how you would do that. On the right side, you can see that I've parented it to an interface, which is to the extensions interface. And then in my code, if I give it a path to an object that implements that interface, the code works. This is exactly the problem, that I want to use this code for. If we look at the relationship, then I'm going to say that default extensions implements extensions interfaces, but dependency inspection, which is the code that loads it, just references it. So that's the quick introduction to the case study. So now let's look at the problem. So this is the project for Dependency Inspector. And so let's dive into that and take a look at, what we're dealing with. So for one, it's a project that has several libraries. So now I'm relating this to concept number one. Inside those libraries are classes or interfaces or VIs or anything else of the sort. So again, concept one. Those libraries build to pack project libraries. So this is concept three, right? I'm explicitly stating and configuring that a library is going to build to a particular type of pack library, and each of these build specifications could configure its custom settings and do whatever it needs. In addition, Dependency Inspector has a top-level VI, the one thing that's going to get invoked when you launch it. And in this case, it's just a source distribution of a standalone VI. So this is concept number 5. When we look at Dependency Inspector itself, so this is the tool running on itself, you can see it has dependencies. It depends on all of these other libraries. And so this is concept number 2, right? The code has relationships. What's the problem? Does anybody want to actually take a stab at sharing with me what my problem is? It's fine if no, I'll just keep going.
Build order?
What's that?
The build order?
Yeah. Okay, so fantastic. All right, so let's take a look at that problem. And by the way, not just build order, but build relationships. So let's take a look. So this is the LabVIEW build today. So let's say that I start building extensions interfaces. You notice that it doesn't really depend on anything else. So my output, I'm great. I'm in good shape. But now I'm going to build default extensions. Well, so notice what it did. In its configuration, it actually pulled its own copy of extensions interfaces. So, okay. But now I build dependency inspection, and it also pulled its own copy of extensions interfaces. And to be clear, if I had a hypothetical my extensions that depended on default extensions, it would pull its own copy of all its dependencies. So I'm making the case that, straight to the conclusion, this isn't what I want. For one, it's code bloat, which means that now everything has pulled its own copy. But worse to me is the fact that the semantic behavior of my code has changed. How has it changed?
Past dependencies are now pointing to the wrong place, right?
Yeah, so let's take a look at what happened. So here is my original source. Both dependency inspection and default extensions had a reference to extensions interfaces exporter, right? Which was the common thread between them. And so everything worked just fine. But watch what happens after we build. Well, they're now named very differently, right? Because when you pull in a pack, when you build a pack library, that actually becomes the base namespace of its content. And so at this point, I've got a, dependency inspection export VI is now looking for dependency inspection extensions interfaces, but I'm providing it a path that's actually default extensions. And it goes, yeah, those aren't the same. And so to me, this is a big problem. So let's look at what I feel we need. So if this is the current output today, I feel like this is what I want, where as things built, I get the right dependencies and relationships. So how would we go about accomplishing that? Well, to me, this is how I figured we would solve the problem. When I build extensions interfaces, everything stays the same. I think we're in good shape. But now I propose that default extensions and dependency inspection now needs to point to the thing I just built, right? So obviously, like you mentioned, where order matters, order in this case very much matters. Obviously, I can't do this until extensions interfaces has built. So that when I build default extensions, well, it's already pointing to the object it's built. So when it builds, it's already pointing at the right thing. And when dependency inspection builds, same behavior. So now if we compare again, it turns out that they're both pointing to the thing I built, which is extensions interfaces, pack project library, and we're back to good. So that's my case there. So let's look at some of the things that I looked at before I jumped down the, my particular path. So the first thing, obviously, I wanted to look at was MGI Solution Explorer. It's a tool that ships with LabVIEW. It's super easy to use. The only problem I ran into is as soon as I tried to build, it turns out that it doesn't calculate that build order, and it obviously doesn't relink those libraries as I needed. So, so to me, this was a non-starter in that direction. I did run into, while asking around, an internal tool that somebody did write, which we called, I guess, internally, Pack Project Library Componentizer. And it turns out it did a lot of the main things I needed, but it was actually very tailor-made for a particular project that we have at NI. And so what I didn't want to do is risk breaking it. And then in the end, I realized that any changes I would have to make actually meant kind of re-implementing everything. So I did actually learn a lot from this one, but I did take the time to do something else. So I'd also need to mention that in LabVIEW, in the single project use case, so where I have all of my libraries inside the one project, one of the things that you could do is when you right click on the library, you can say replace with. And if you point it to the matching Pack project library, it takes the time and updates all the callers. So from a manual standpoint, this is a decent alternative. My problem was it is manual, and for me, automation is fairly key. So, but this is an option that does exist today if this is a use case that could solve your needs. The other option was, well, I could make all of my libraries have their own project where the source code actually depends on the built Pack project libraries already. The problem with that to me was developer efficiency, where let's say that I was in replace with, yes, I think so. So the question is replace with for PPLs LabVIEW 2019. There's a lot of improvements on that in 2019. I'm under the impression that that menu entry existed prior in the project. However, like I said, there are improvements, and the programmatic way to do it is in 2019. That's what I'll talk about. Yeah, and there was a comment that said that 2018 is probably when it was introduced. To be fair, 2020 has a lot of improvements. So originally when I wrote this, I wrote it in 2020. But the LabVIEW team has done a huge amount of effort. There are probably still some corner cases that may not work, but so far I have not run into those. So there's my pitch for LabVIEW 2020. So in the multiple project case, the issue that I ran into was that if I needed to make a change in the packed library that I depended on, well, I couldn't just make that change. So what I had to do was close the project that I had open, which was using that packed project library, make the change in the other project, rebuild it, and then reopen my project so that I could use the built output. And to me, this was really a killer in my productivity. So I put that as a con right there. To be fair, there are likely a few other alternatives that I'm not aware of. So if you yourself have written one of these solutions, I obviously just didn't know about it. So let's talk about Solution Builder. So the first thing I want to go into is just full disclosure. It's not an NI product. It's an open source project that NI employee and huge LabVIEW fan created, aka me. I've had a lot of discussions with the LabVIEW team on this topic, and it's been very exciting. So, you know, I'll just leave it at that. But it's a problem that is well recognized, and the tool is supported in LabVIEW 2019 because I am using a method that is made public in LabVIEW 2019. So let's look at what we're doing. So in this case, if we look at the dependencies that we looked at before for Dependency Inspector, it's easy to notice that when you order them in a certain way, there is a build order, which maps out very nicely. And so when you launch and run that on Solution Builder, you notice very quickly that the build order actually matches the order in which it is necessary to build. So to me, this is proof that the algorithm for determining our build order is correct. So let's take a look at implementation. So what Solution Builder does is you can point it to a project or some projects or multiple projects, and it will look at the build specifications, because in the end, that's truly what we care about, is what it is that we're about to build and what is the order in which they need to occur. So once we have that information, we then have to ask those source items that we're about to build for their dependencies. And so we query those, and then based on those dependencies, we then calculate the dependency order. Once that's done, and we know what order we need to build in, it's just a matter of going, hey, did anything build previously? If so, do I need to point to those? And what we do is we now invoke this node, this method that's in LabVIEW 2019 onward, that basically passes it a project item reference and a path to the newly built item. And then in this case, I'm just telling it, hey, go ahead and trade it out. And so this is what it's doing under the hood. And then once that trade is made, we just call Application Builder, just no change, just the native Application Builder within LabVIEW. And then once that's complete, we repeat step 4 until there's nothing left to be done. And so at each stage, we just ask it, do you need to replace these items? Yes, no, do it, build. And so this is just what happens. If we look under the hood of what actually takes place, so here's the project and here's the cascading build sequence. Basically, we say, hey, we notice the first, notice it's LabVIEW object interfaces. So we build it into a packed library. We then invoke the node with that information, and the substitution gets made. After it gets made, this is what the project would look like. It basically removes its dependency on the original library and now adds the built one as a dependency so that all the other elements can now reference it. Repeat that process for stage 2, and now you can see that we're accumulating these dependencies within our project, and we're substituting them for the originals. Do that the entire way through, and now all the packed project libraries have become dependencies, and we're ready to build our final source distribution. Compare of the before and after, and this is what you get. So here's a list of some of the features that got put into to Solution Builder. So one of the things I wanted was not just to have a single project, but potentially build across multiple projects that may have dependencies on each other. So obviously calculating the build order, but I also wanted to make sure that we had some more advanced use cases. And since we seem to be doing okay on time, I'll actually go into these a little bit. So the thing I also want to remind you of is that if there's any missing features, as I mentioned before, this is an open source project. At the time that I posted it, I didn't have Michael telling me about the other options that I had. So right now it is on GitHub. That is where we've got the items. It nicely accepts, I put on there, I said accepts contributions. But yeah, so shout out otherwise to G Central. So yeah, by all means, go ahead and let me know, or even if you're not willing to or feel confident to make those contributions, list it as issues. All right, so diving into some slightly more complex use cases that I felt I personally needed in order to be able to find it useful. So we talked about default extensions, and in this case, we talked about the extensions interfaces, which builds a PPL, and in this case, they're all within the same project. So this seemed like the simplest use case. But there may be situations where you actually depend on code that is on in another library based on another project. Maybe it has specific needs and it needs to be part of its own project for some reason. But I felt that was a use case that needed to be solved as well. And then obviously, what if my code already depends on a built PyProject library? Well, in this case, this is really a no-op because you wouldn't have a build specification. And I just wanted to list it here as, yes, this obviously works just fine. Yeah, one of the questions was about the link to GitHub. I can actually post it in the comment. It is also it was the title of that slide in the presentation. So if any point you forget, feel free to refer back to the slides. Yeah, exactly. And then the last use case, and this is actually one that I was especially passionate about when I realized I needed this, is that I may depend on a library or a built Pike library that I don't own. In this case, an example of this would be, let's say that I work with another team at NI and they build code into a Pike library that I know I use. But to be fair, I do also work at NI, which means I likely have access to the source. What I don't want is to make a duplicate version of their build specification. Right. So what I didn't want to do is add that source and have my code rebuild it, because if they make changes to that build specification, I don't want to be in charge of trying to keep up a duplicate copy. But I still have the source. And so one of the use cases that Solution Builder lets you solve is if your code points to original source as a library, you can actually tell it, hey, when a client goes to you, when you go to build something that depends on this library, substitute it for this already built one. You just don't have to build it yourself. And this is fairly advanced, but I see this as being much more common and prevalent. I certainly ran into this, so I needed this. Okay, so there's a question. So how do you handle when you want to deploy solutions to different targets? So inside, so what Solution Builder, will do is it will actually parse all the different targets. And so in this case, by default, obviously it'll look at my computer, but if there are others, it will actually go through those and it would just show them as different build outputs in the window that you saw. I'll be fully honest, and I haven't tried it. I know how the code is written, and I know that I do numerous different targets because I work a lot with RT systems. But in this case, I think this would be definitely worth me trying and making sure that works. It is a use case that I badly want to work if it doesn't already. Question is, does this work if you use a library within the same project, but different types of targets? So that probably piles on. I have not tried that, and we could give that a shot. Yeah, same question. All right, so let's take a look at a different project. And in this case, this is the example of the more complex scenarios. So for one, it's again a project with several libraries. 2 of the 3 libraries have a built specification. The one on the top called sample common lib, there are cases that you may want to actually pull in that library. Let's say that you don't care so much about the namespace, but you actually have a shared API that you're not interested in breaking compatibility between different builds or different clients. You may want to ask your clients to pull in a copy of that code, right? Let's say it was just efficiency gains. This is something that we do on occasion. In this case, both of those build specifications at the bottom actually are configured to pull in sample common lib on purpose. But that's a use case that I wanted to make sure also worked. So if it doesn't have a build specification, it's pretty much a no-op. The other one is there's external libraries and external dependencies. And so this is a use case of, I believe external lib is one that I have the project. It's a different build specification inside that project. And then external deps, which is listed in dependencies, is one of the more advanced use cases of this is a library I have access to, but I don't own the build specification, but I do know where to find that built version. And so I get to specify that. Let me check something on the questions. Yes. So LabVIEW can't currently handle multiple PPLs with the same name but different targets. Yes, I believe there's a limitation. I'm trying to think if there was a workaround to this. Nothing comes to mind, but I'll make a note of that and try to address it either in the README file of the project, but just to make sure that anyone looking to use that doesn't run into a pitfall that I could have warned them about ahead of time. So there's the okay. The other thing I wanted to support looking at this project was all the different kind of build specifications. So this is an example of having all the different build specifications that to support. You'll notice that a zip file is missing from this. It turns out that zip files work on source on disk. And in this case, all of these substitutions that I'm making are actually in memory. One of my original goals was not to modify the original source. So all of this happens in memory. So a zip file will actually just try to bundle what is on disk. So the way to get around that is to actually build twice. You would build all your exports, all your build specifications, and then have a different project that all it would do is build a zip file. So, right. And so when you open up a solution builder, this is what that output would look like here. It noticed that external DAP actually does not have a project associated with it. And so we omit that from the UI. We basically claim that it's already built because you pointed us to one. The next line, second line down, is it's an external library, but we do have access to that project. It's listed. And so we figured out the build and realized, oh, well, we can build that next. And so it puts it in the next build order. And then it builds everything else. And then this is a compare of before and after. You'll notice that everything happened the way that I wanted, where dependencies have been switched over. They went from libraries to pack project libraries. And you'll notice inside the middle is that sample lib actually did pull its own copy of sample common lib, which is exactly what I asked it to do. So that's actually about it. Just to remind you guys that this is, so it's on GitHub at the moment. I welcome contributions, and should you need to ask anything, by all means, ask. So let's open it up for questions. Thank you.
Hey, Phil, you had a summary slide with things it can do. I mean, you went past that quickly. I mean, can we go back and just have a look at it again?
100%. Right. There. Yes.
Okay, so command line is already supported.
Yes.
So okay, that's good.
Yes,
yeah.
I meant to highlight that. I'm sorry. Yes, absolutely.
So Nicholas has a question. Please go ahead.
Okay.
Hey, Phil.
Thanks a lot for the presentation. It looks like a really awesome tool. I have one question more in the general scope. So on my team, there's people doing .NET, Python, and a bunch of LabVIEW developers. And we are always envious about how easy it is for all other languages to set up CI/CD. And your tool looks like really one missing piece along that direction. And I was wondering how that would play along with either JKI's Project Dragon, or if you are aware of whether NI is pushing also in that direction.
I don't yet know how it relates to Project Dragon because I only found out about it a few days ago. And so my goal is to learn a lot more about that. So in this case, what I'm trying to still get to learn is this is trying to do the build output, not so much manage package dependencies and all that kind of thing. So if there's more information on the JKI Project Dragon that I need to learn about, and Eric just volunteered to talk a little more about that. So, but the brief summary from my perspective is I don't have a good answer to that at the moment, I'm afraid.
Okay, thanks.
Eric. Yeah.
Sorry, apparently I have mute right on. So Project Dragon, initially at least, I mean, we're in talks with JKI about the plans they have with Project Dragon because it's a fairly exciting project actually. So Project Dragon's initial focus right now is how you define relationships on packages at the project level. So you can declare that your project has a relationship to a specific version of a package in the project itself. So that's a functionality that LabVIEW today doesn't handle, but would be pretty useful. And it's somewhat related to what Phil's talking about, but what Phil's showing here is the dependency management when you're dealing with PPLs, which Project Dragon doesn't directly address, right? It's different problems, but similar.
Exactly, but it would be like two bricks in the CI/CD pipeline that you somehow still have to manage manually with whatever build pipeline you use.
I agree. I think, there's a lot of interest between both NI and JKI of seeing these technologies play well together, but they are looking at different problems independent from one another currently.
Exactly. I have the same feeling. So more holistic approach would be, so I don't know if JKI and NI working together to solve the whole issue or the issue as a whole would not bring the community way more forward than one tool and the other. But this is slightly off topic, I have the feeling. But nevertheless, thanks a lot for the very cool tool.
Yeah, no, absolutely. I think configuring your build pipeline to be able to invoke the tool from your existing tools or scripts, and then at some point storing whatever gets built in your artifact repository so that as you build your larger applications, then potentially you'd be able to use what got built. But in this case, my goal here was reduce code bloat anytime that you build, and more importantly, solve the problem of being able to dynamically load these extension points, which, like I said at the beginning, I care very much about, clean architecture and being able to create infrastructures that have good extension points. That's a very tough problem to solve without this. All right, so here's the question that I was dreading. Thank you, Ethan. It talks about PPL support and malleables. So hopefully you're aware of malleable VIs there. A malleable VI is a dynamic, in a way, input and output sub-VI that adapts to the types that you pass it. There is still a limitation today if you have a malleable VI that is on a project library boundary, which means that if you try to have in your library a malleable VI that you want used by external clients outside of that library and invoke it, basically, I believe your pack library won't build. It'll say, yeah, no, you can't do that. That is still the limitation today. It turns out that Dependency Inspector does, the case study does use malleable VIs, but they're just internal to each pack project library. in case you're wondering why this is a limitation, is that it built a pack project library is compiled, and unfortunately a malleable VI, when you use it, needs a way to recompile and adapt to its inputs and outputs. Obviously, you can't recompile something that is already compiled, and so that is a bit of a limitation today. Still a limitation today. Ethan, no worries.
So Phil, I mean, so the MGI tool is an open source offering, isn't it? I mean, so wouldn't it be better to add this capability to the MGI tool?
So I'm happy that you mentioned that. They're the first people I called. So Eric set me up with a call with the MGI folks. They were great to talk to. What they reminded me was that MGI Solution Explorer at its core simply invokes the LabVIEW's native application builder. And so their reply to us was, you know, if LabVIEW implements this, we would just get it. It turns out that they don't really add a whole lot of special sauce to be able to do what the code I have is trying to do. So they would just love to be clients of that and not have to pull that in. That's not where their source code aims to be.
Yeah, but the thing is, I mean, it supports extensions, right? I mean, so you could create your own step if you like. I mean, and this could have been one of the steps in the MGI Solution Explorer. Right. And I mean, you know, so which means that I mean, this is already shipping with, I mean, our MGI is already shipping with LabVIEW, and this would have been a nice addition, like a new plugin to it.
That's right. Yeah, I don't recall offhand why that it didn't end up being the suggested path forward. It may also have been the fact that the support here is 2019 and beyond. But yeah, I don't plan to close that discussion with them. We had a couple of great calls, so we might keep that going.
So Eric has his hand up again. So
I was just going to ask Phil to comment a little bit. There are, I believe, Phil, in your code right now, you're still using access to private methods that MGI would not have had access to. So there's a reason that they couldn't have implemented it exactly the way that you've done it. But we've been working, the dev team for LabVIEW has been working with Phil trying to resolve that conflict. There's a question in here from Taggart Sam about what versions of LabVIEW this will work for, and I'm pretty sure you're still using methods that only existed in certain versions of LabVIEW.
Yeah, 2019 and beyond. Yeah.
Okay.
Yeah, and just to add a clarification, one, I have no idea what private methods are, but that's not true. Yes, I am. Use the perks of working at NI. Given that the code is in source code control, I had no choice but to password protect one or two VIs, simply that calls into code that is not fully public. And like Eric said, I'm working with the LabVIEW team specifically to see how we remedy that. Because I personally don't like having that kind of code closed off, but I put it to the minimum subset that I possibly could.
Yeah, I think Sam's question is, I mean, can you have a PPL built in 2017 and or 2019 and then have that as a dependency in 2020, and then would it still sort of pull that in?
So if you have the flag to say supports future versions of LabVIEW when you build your pack library, you should be able to do what you said out loud. I'm trying to read to see if that's the case, if that was the question. But yes, go ahead.
I was just saying, my question was more of an MGI Solution Explorer. You could have multiple build steps, and some could be in LabVIEW 2017, some could be in 2020, some could be in 2019. Does your solution support that? So if I try to build and I reference a PPL where I have the source code in 2017, will it load the source code in 2017 and build in 2017, I guess, is where my question was coming from.
Well, I'm going to assume you're asking, let's say 2019, because I've stated that this thing will build. So, but I understand your question. So in this case, I think you would have to build them. If you try to invoke that as a single step, this is just LabVIEW code. It doesn't actually invoke an instance of LabVIEW in order for which to build, which is what MGI Solution Explorer does.
Okay.
So in this case, you would just end up calling the LabVIEW 2019's LabVIEW EXE give it the path to Solution Builder, it would build whatever you asked it on the command line or the UI. And then when you're ready to build your 2020 things, you would invoke LabVIEW 2020, build it, and that would be that.
Thank you.
You're welcome. Yeah. And by the way, if that is a use case that you all were thinking that, oh, maybe consider, one is I'm obviously not trying to replace the MGI Solution Explorer. To me, this is a stopgap to an important problem, and that's why I, working with Eric and people like that to be able to go, can we open source this? The response was amazing, but I'm really just trying to help our community go, because anytime I've asked about PPL adoption, the answer isn't quite what I hoped, and a lot of the challenges were regarding this problem that people hadn't quite solved. I even had one person tell me, I wish I was at a point where this was my problem, but our code isn't even there yet. So now at least they have they could approach that problem the right direction. Thank you all so much for having me. Thank you.